So a little quick. Oh, it can work. Oh. Okay, I'm seeing everyone's back and we're ready to start again with this new session this afternoon, where we are going to talk about data cleaning with OpenRefine. How do we find that? Well, if you go to your schedule page, you can click on data cleaning with OpenRefine, and that will bring up a page like this. And this gives a basic schedule. In the setup section here, it's asking you to, excuse me, download the one file that we're going to be using this afternoon. This is this link up here. And if you download that file, opens up, just put it somewhere where you can find it, save the file somewhere you can find it. We're going to use that in a minute in OpenRefine. I'm assuming we've all managed to do that. I'm also assuming that we have all managed to download the OpenRefine software and get it installed. Okay, I've already got OpenRefine opened on my machine, but I'll go through it again, show you how I did it. I've got a Windows machine, so I downloaded OpenRefine, I unzipped the file, the folder, which gives you another folder, which I've placed on my desktop. I think I've renamed it as well. But in the basic folder, you've got everything you need to run OpenRefine, and I just double-clicked on the OpenRefine.exe file. Slightly different in Mac, but again, it boils down to you double-clicking the program from your program launcher. When OpenRefine opens up, again on Windows only, you won't see this on the Mac side. What you get is this little DOS type box, which once it's started up, you can quite happily minimize and ignore for the rest of the afternoon, because what happens is that OpenRefine runs in what's called a Java VM, and the Java VM or the program in the Java VM talks to you via your web browser. So up here in my web browser, I have the initial page of OpenRefine. What it will do is it will actually find out what your default browser is, and it will open OpenRefine in that default browser for you. So hopefully it should, if you didn't have a browser open, it should pop up on a screen like this and show you this. And this is the basic layout of OpenRefine. We'll come back to that in a minute. Remember, everything is in the browser this afternoon. Okay. So downloaded the file, we've downloaded the software, we can load the software up. So into the episodes, introduction. Lesson, motivations for OpenRefine lesson. Why do we want to use it? Well, some of the things that we'll mention this afternoon, we've probably already mentioned this morning when we're talking about spreadsheets. But OpenRefine allows you to do a little bit more data cleaning on your data, and it overcomes some of the slight shortcomings of Excel. So we've already had this point here. Important to know what you did with the data, and the fact that journals expect you to have copies of the data and the details of the steps that you took when you were manipulating the data in whatever way you did. First sentence. This is really relating back to the fact that, as we said this morning, you never change your original data. Okay. Now, in the Excel lesson this morning, we kept saying, oh, well, use a copy of the original data and all this sort of stuff. Well, OpenRefine is sort of going to handle that for you, because when we open a file in OpenRefine, the file you open is your original data. But from there on in, everything that you do in OpenRefine is actually done on a copy of the data. So it will automatically preserve your original data. That's one problem solved. And that's what I emphasize in this line here. OpenRefine will not write back your original sources. Phew, isn't that a good thing? Yes, it is. But it does mean that you have to remember to save your work when you're closing OpenRefine. And again, later on this afternoon, we'll see ways of going out of your way to save the work and make it reproducible on other copies of OpenRefine. Any operation that changes the data in OpenRefine can easily be reversed or undone. Again, we'll see that, and we'll do examples of that as we go through the lesson. Of course, it can only reverse and undo and redo things if it is, in fact, tracking everything that you do. Again, exactly what you wanted to do. Data is often very messy. Well, I think we saw that this morning. And this tool saves a lot of time in cleaning headaches. Yes, there are various things it can do which are sort of similar to Excel, but some of the ways it does this are quite a bit more sophisticated. Data cleaning steps often need repeating multiple files. So take an example that you're collecting data on a monthly basis, and because you can only have one tab per file in your spreadsheet, you're going to have a file for January, February, March, and so on and so forth, or years, whatever. And at some point, you're going to want to perform the same operations on each of those files. So what OpenRefine will allow you to do is perform all operations on one of these files, save a list of instructions, if you like, and then allow you to apply the same set of instructions to the next file and the next file. It does rather assume, though, that the files are of the same format. That allows you to speed up repetitive tasks. Some concepts such as clustering algorithms are quite complex. Now, don't worry about the term clustering algorithms. We'll go to that in a minute. Yes, they are complex, and we kind of use them a bit like a black box. There are various options available to us, and we pick and choose the one which gives us the best results. There's no hard and fast rule. There's no complete solution when we're using the clustering algorithms. But again, when you see what it does, you hopefully you appreciate that. Well, that's a useful little trick to have in your toolbox. Okay, that's not really telling me anything. Okay, so before we get started, it's a bit I've already done. We've downloaded the files. We've got OpenRefine installed. I think I've mentioned what OpenRefine is. It's a Java program, but it interfaces with the user, that's you and me, via your default web browser. And it all does that. When it opens up, it does that, makes that connection automatically. We'll talk about reversing instruction, reversing what you did. That's all right. Use to standardize and clean the data across your file. Well, yes, that is kind of why we're using it. It can help you get an overview of a data set, and it does that in very similar sort of ways as we could do in Excel, I suppose. It resolves inconsistencies. Now, this is where we're getting down to its speciality. It will bring together the inconsistencies and allow you to do something about it. It allows you to split the data up into more granular parts. That's just another way of saying you can filter the data and see parts of your data set and sort of like put the rest of it into the background. That's particularly useful if you're using a very large data set where, you know, it's just impractical to see 50,000 or 60,000 records at a time. If you want to find more about OpenRefine, it's a free open source tool. It used to be called Google Refine, and then Google made the code open source. And now it's freely available, and it's maintained as open source. They do got their own little website, which I'm going to take you to for one very specific reason, because on the OpenRefine, did I click on that? If you go to the OpenRefine site, which I can't get at the moment, the OpenRefine site gives you various little information about the community, because it's open source, documentation, downloading, what have you. And if you go to the documentation, the two things I want to point out to you here, one is online courses, Data Carpentry, OpenRefine for ecology. So we get an honourable mention in the OpenRefine website. The other thing I always point out is this book down here, using OpenRefine, the book. It is, in fact, as far as I know, the only book that's ever been written on using OpenRefine. And it's probably getting quite old now. So anyone who likes OpenRefine, there's a writing opportunity there in writing the second book. Let me just close my mail for a minute. Oh, it is closed. Right. Okay. If we've got time at the end, we'll come back to look at some of these other little resources which may be available. That's about it for that section. So the next thing we're going to look at is actually how do we start using OpenRefine, working with OpenRefine. The first thing we need to do is create a project. So at this point, I'm now assuming that we all have OpenRefine opened up. Oops, not that one. Let me just, I wish I knew how to get rid of that. There we go. Just want to get rid of that. Did open that twice. Okay, so this is my OpenRefine initial screen. Okay. If anyone hasn't got that, can we have a little show of hands? Or show of hands, say, yes, I've got a screen which looks very much like yours, Peter. And obviously, if you're having difficulty, please do use the red no sticker, and someone will get round to helping you out. Okay, I think most of us are there, so I'll press on a little bit. Okay, so this is the initial screen, and there's not a lot in it really. Right down on the left-hand side, it defaults to assuming you want to create a new project. If you're coming back to something, you can look at see what projects you've opened in the past. And this is the one that we're actually going to use, but that was just me testing things out. You can import a project, which we'll come back to later on, and something I've never tried using, but you can have it in foreign languages as well. So back to create project. Now, first thing it's going to want to know when you create a project is what file is your data in. And we're going to use a CSV file that you downloaded, but you can see at the top here, other file options are available. In fact, quite a growing number of data types or data formats are available. But we're just going to keep it simple today. We're going to just use a simple CSV file because I say simple, but of course it is the majority of the files that we're likely to come across. How do we get the file? Click on the browse and find out and just navigate in the normal way to wherever you left the file. So this is the one I downloaded. I'm going to just click on OK. And all this actually does is it writes the name of the file on the screen for you, so you know what file you're working with. That little one in brackets is just because I've downloaded this more than one time and they're sitting in the same folder. So it's the same file as you're going to be using, quite possibly without the one. Having got that file, I'm just going to click Next. And what's going to happen now is OpenRefine is going to open that file, have a quick little read of that file. It knows it's a CSV file. I would point out, we know it's a CSV file because it's got .csv, so we're assuming it's a CSV file. OpenRefine actually reads a file and then decides it's a CSV file. Okay, and it also makes other little guesses as whether it's a CSV file or a TSV file by working out, if you like, what the delimiter is. It also does other little interesting things. The most obvious thing is at the top, you get a little grid of the first few records in your file. And basically, if this looks like a table, then the chances are it's made all the right guesses. So, for example, it's worked out that there was a header record in the file, and these are your column names along the top. It's obviously worked out that these columns are separated by commas, because it's put everything in its own little cell quite correctly. Notice that one of these fields is called JSON. Now, I'm not going to go into JSON. This is a little example of JSON down here. We don't need to worry about this too much. But notice that within the JSON, I'll find an example. There's an example of a comma at the end there. And you can see that everything is, JSON's a bit weird that things are often commas anyway. What am I saying? A lot of the items in a JSON record, if you like, are put in quotes. So engine version, what have you. But what you can't see is the fact that it recognized that this whole section down here is effectively in quotes. Therefore, the commas inside it are actually commas. They're not separating out new values for the next column. Okay, that's very much what we were talking about at the end of the Excel lesson, where if it's got commas in it, it would automatically put it in quotes for you. And this is just doing the reverse operation. Okay, so we've got lots of things up there, and it looks good. But down at the bottom, if it got things wrong, you've got options at the bottom here for changing things. Type of things it may get wrong is, if we look at this little list down here, ignore first 0 lines at the beginning of the file. That's useful. I mean, it's not doing it in our case, but it's useful, for example, if you had some kind of report file that had multiple headers at the top in the first few rows. Yeah, it's then saying tick this one, so it's done this one, pass the next one line as the column headers. Yeah, exactly what we want, i.e. the first line in the file as the column headers. We can say discard initial rows and load at most rows. Now, you might want to use these if you just want to put a section of the file. It's a very large file, for example. You may just want to do a little bit of experimentation and exploration and just use part of the file. Use the character quotes to enclose cells containing column separators, much as we do for importing and exporting any CSV file. Store blank rows as opposed to omit the blank rows. Store blank cells as nulls. Now again, if we come across, and I think we will come across some empty looking cells, internally it knows that's a null. You just won't see anything on the screen, which is pretty much what you'd see if you're looking at the CSV file directly. On this side, we have things like the character encoding. Again, UTF-8, it says recognize it's UTF-8. Oh, didn't realize it would do that for me. I've selected that and it tells me all of the ones I could have had. But UTF-8 is by far the one you're likely to want, so that's all right. Comma CSV, yes. Option there for TSV. Option there for custom. So if I was to click on custom, I could put in here, you can't really see very well, but it's actually under custom, it's actually got comma already in there. But I could change that to something else if I had a specialized file which has its own delimiter in there. If I was to say TSV, this is what the effect of saying TSV. I'm telling it now, this is a tab separated file. The columns are tab separated. Well, the reality is they're not tab separated. So what's going to happen? It reads the first row. Yes, it still decides that's header, but this is all now being treated as one comma because it's searching along there looking for a tab character, which doesn't exist. Okay, so if you open a file and it looks something like this, where there's only one column and everything's bunched together, the chances are it's not delimited in the way you think it is. And the most obvious way, TSV files are often called .tsv, so that's a bit of a giveaway. But as I pointed out this morning, for the comma-separated files, European files could well be using semicolons, and you'd get that effect there as well. Yeah. But this option here allows you to effectively override that into your custom and put a semicolon on it. Okay. That's about all I want to show you on that. The other thing right down the left-hand side here, again, is just another list of all the different types of files it can handle. So it can explicitly handle JSON files as well if you've got that. Okay, this is just a preview. So what do? If we're happy with the way things look, and I think we are, what we're going to do now is just come over to the right-hand side here and say create project. Okay, click on create project. And now the display looks very much like the top half was showing you before. But now we can page down and see more records. By default, it only shows you the first 10 records. But at the top here, you've got the option of going up to 50, which I would recommend we do straight away. It just means we can get more on by going up and down. If you need to see more records, you've got next, and you can move backwards and forwards to move the records. So your file setup. Now, from this point on, essentially what you're looking at there is just a copy of your file. Anything we do to what you see on the screen is just happening on a copy of the file. That's very important. Oops, where am I going? Okay, create a project. We've created a project. We've chosen the file, we've done the next, we've looked at the preview. The first aspect of OpenRefine proper that we're going to look at, and we've got our project started, is this notion of faceting. And faceting is something that you do to the rows based on, or you choose a column to do the faceting on, and it's a way of grouping different values within that column. So what we're going to do is we're going to look at this, we're going to start with a text facet. I'll show you all the different other facets we can do. And we're going to do this on scientific name, which is one of the column names. Okay. This is, I keep looking at the bottom when of course it's at the top, isn't it? Silly me. Okay, so scientific name down here. I'm not going to try and pronounce any of these, but these are scientific names. And you'll see that each of the columns has a little drop down. And if I click on the drop down, I get lots of options. And the one that we're interested in at the moment is this thing called Facets. And the type of facets we can have are text, numeric, timeline, scatter plot. We'll cover all of them eventually. We won't look so much at the custom ones, but they are available there to do more complex type of filtering and grouping of the data. So I'm just going to go for a straightforward text facet. And you'll see that on the left-hand side, I get this little box. You can move it around. I don't know why you'd want to, but you move it around. And what that is doing, or what that is showing you, is for the entire column of scientific name, I should have pointed out up at the top here, tells you how many rows you've got in your data set. 35,549. For all of those rows, it's looked at the scientific name and it's grouped them based on the name it's found. So I don't, can I just, perhaps I want to make this all just a little bit bigger for everyone. Just bear with me. Okay, makes it all a bit bigger. Oops, didn't mean that. So you can see down here that all the various different names, some have lots of the same, because against them is the count of how many there are of each name. Okay, and at the top here, it tells me that there's a total of 26. They are currently sorted by name, alphabetical order. I do have an option of saying order them by count, in which case I can see that this, whatever the pronunciation of that is, has 10,596 entries. And if I go down to the bottom, there's a lot of blanks, interestingly enough, and there's quite a few which only have ones. Now they could be very rare species, or they could be typos. Okay. At the moment, we don't know, because all we've done is essentially it's a filter. Faceting is like a filtering, because if I now let me just put them back in name order. if I pick one of the ones which only has a few, like this one, if I click on that, then you can see in the main part of the grid, I've now been reduced to only the 7 rows which have that scientific name. Yes, so it's a very quick way of filtering your data. Having got that, I can either say remove all or reset all, or I can just say exclude. And then I'll go back to what I had before, because now nothing is selected. If I just hover over this, you can probably see on the right-hand side of this panel, I've got 2 options. I've got edit and I've got include. Well, include is effectively the same as me just clicking on it. So here, if I just include that one, by default, if I've included that one, everything else is excluded. Yes. And if I exclude that, i.e. nothing is included, therefore everything is included, if you like. So it's just a quick way of toggling between what you want. And of course, the advantage is that I could include that, and I could include that, and I could include that. Yes. So 3 each have 1 with 3 different names are there. So I can group these manually, if you like, into little groups like that. I'll say remove all. Oh, I beg your pardon, that's removed my facet. So how do we get the facet back? Little down arrow, facet, text facet. And there we are, back over. Okay, so little various things you can do on that. And just see how far we've got. Scientific name, text facets, hover the mouse. Yes, you've got an edit function. I didn't. You probably saw the edit function, but I didn't try to use it. So if I go back and have a look at them again, oops, at the top here, you can see, ignore him for a moment, but this one has got 435. And then below, above and below it, it seems to have 2 very, very similar named items. This one in particular looks to me if it's just got an extra I added on the end of it. Now, in cases like that, one thing you can do is you can click on the edit and you can manually change that name. Okay, safe to do that because, of course, we're only working with a copy. But if I'm not going to do it, but if I did change that, if I knocked off that last I to make it match the other 435, I would then have 436 of them. Okay, I'm not going to do it because we've got other ways of grouping things together like that, or potentially detecting and getting rid of typos. Edit function, yes. I'm not going to do it. I've just said that. I don't know what that solution is telling me to do. Yes, that's pretty much what I've just told you. Lots of same example. Almost identical, probably typos. Okay. The link there if you want to know more about faceting, but I've already mentioned the numeric facets. We'll get to use these. We'll do an example of a timeline facet and the scatter facet we'll try. Won't bother with the custom facets, but there's enough there for you to get the idea of what they're going to do. And this is really just explaining the numeric, what they do. The scatter plot does display a graph. The numeric one is more of a little movable scale, but we'll see that when we get around to it. And the custom facets are specific custom facets if you want to do word counts, so words within text and what have you, which can be quite useful, but we're not going to go into that. So, a little exercise for you. Using faceting, find out how many years are represented in the census. I think you'll find in a column named years. Is the column formatted as a number or a date or text? And how does changing the format change the faceting display? Which years have the most and least observations? I would suggest you do them in slightly different order. Do 1, 3, and then have a think about 2. Okay. So we'll give you a few minutes for that. If I can just find my little timer. Shall we say 4 minutes? and off you go. Okay, so it's a very similar exercise as what I've just done, only you're going to use a different column. And perhaps the thing I didn't, I did put out, you can do it in count order as well, and it will automatically highest count first. Okay. Oh, didn't set that going. Oh, you've had extra time. Okay, we'll have a go at that. There's 3 things being asked for. So this is the year column. We've got various years in there. Facet, I'm just going to say text facet, just as we've done before. Now I'm just going to close this other one because it gets in the way. Okay, it doesn't change anything because I didn't have anything selected on it. So now we've got 25 choices for year, going from 1977 down to 2002. I think the name of the file might be a bit of a giveaway there. So we're 27, but they're currently sorted in text value order. And of course, because of all years, they turn out in the right way. What we will ask for is years with the most and least. So what we want to do is to sort that list by the count. And then we can see that the highest is 1997, and the lowest was 1977. Okay, and that's treating it as a text, treating these values as text. And in reality, when you import a file into OpenRefine, it initially treats everything as text. And sometimes you need to change things, sometimes you can get away with using them as well. So for what we actually wanted to do, leaving that as text probably worked quite well. Okay, but the reality is that these are really numbers. Yeah, so perhaps what we might have done instead is gone into Facet and said numeric facet. And if you can see here, it says no numeric values present because they're all text. So that doesn't help us much. So what we can do is, before we do that facet there, we want to change these year values to be numbers. How do we do that? Again, everything is from this drop down. We want to edit the cells, common transformations. Oops, I beg your pardon, edit the column, because we want to do for the whole column. Just bear with me when I move my zoom screen that way. We want to edit the column, and we want. I'm lost. Edit cells. That's right. We'll edit the cell values. We want to use a common transformation. By common transformation, transform means change it in some way. Common just means a set of things that you commonly want to do. So as everything starts off as text, it's quite common for us to want to change it to either numbers or dates. So in our case, I'm going to change it to numbers, but while I've got this open, just have a little look at some of the other things you can do. Title case, uppercase, lowercase, dates, and empty strings, and what have you. Okay, but we're going for numbers at the moment. And what will happen is, one, they all turn green to show they've changed. You get a little note, a PS, saying how many cells it's changed, which you can ignore. There was a little slight change in here, but nothing noticeable, because again, as they're just years, it doesn't really matter if you're treating them as numbers or text. They're still going to sort in the same way. But what it does allow us to do now is to go to the facet and say numeric facet. And you can see down here now, we have the numeric facet. And you can see it's a little, like a little histogram or bar chart, well, histogram really. Well, histogram, bar chart, much the same in this case, because each bar represents 1 year. Okay, now when we had this type of filter, a text type filter, what we could do is, if we were interested in the 1997, I could just click on it or click on and include, and it would filter to 2493, just as I've got written up there. If I undo that, and then I also said that if I want multiple ones, I can click on them and click on it and click on it and so on, and build them up. Okay. Just want to go back to normal, what we had before. So you can do it using a text type filter. On a numeric filter, what you effectively get, you get this little bar charty thing, and you get little handles at the beginning and at the end, and you can drag these in order to do your filtering. So looking at that, this one about here and here seems to be the biggest, yeah. And you can see there that, again, 1997, okay? So this has, it's probably a quicker way of doing ranges of years. Unfortunately, you can't do discrete years as we could have done on that. But it seems more likely that on a continuous variable, you're going to want a continuous range of values to be selected. Okay, so you just drag and drop the handles like that. Okay, the timeline function, there's not much point in just saying it as the date there, but the timeline function works in a very similar way. You get this little graph and the pull handles so you can get a time range or a date range if you had them as dates. All right, any questions? Excuse me, any questions? If not, I'm going to move on. Okay, the next thing we want to look at is clustering. Clustering is based on the faceting, but it's a bit more subtle. We'll start off by faceting, and then we ask it, excuse me, to cluster. Go back to where I was. I'm just going to, I like to clean up behind me as well as I get hopelessly confused. I'm also going to, oh, well, I can just get rid of that. I want to go back to my scientific name and set up a text facet as we started off with. Okay, much as we had before. And you'll notice what we have in here is a little button named cluster. And if I click on the button called cluster, we get a whole new screen opening up and saying no clusters were found with the selected method. Well, that doesn't sound too promising. What is the selected method? That's the question. Well, we've got a method called either key collision or nearest neighbor. And within that, depending on which one of them I pick, I've got various other little functions. So I'm going to stick with key collision and I'm going to change this to metaphone 3. Okay, you can try all of these in turn if you want to and see if they give different results. Possibly they will. Let me just try a couple of the other ones. Fingerprint, no. No. Oh, that's got found something. Well, that's found even more. Okay. Now, what all these different approaches are trying to do is look at all of these different values of scientific name and try to say, are they meant to be the same or not? So going back to this one here, which is the one I think the notes suggest we try and look at, what we can see is it found 2 clusters. And what it's saying is, what it is sort of suggesting to you is, perhaps these are in fact typos for the same thing. Okay, so if we look at this one down here, this is the one where we spotted almost immediately. They look as if they're all the same thing. And what it's going to allow you to do is, it's going to make a suggestion, well, given that I've got 435 of them and only one of the other 2, they're probably all meant to be that first spelling. And if I tick that and say merge, I'm potentially going to merge them in a minute. Okay. And equally for these ones, do I think they're all the same? I'm going to say yes. Notice that here we've got one starting E, but other than that, the spelling is exactly the same, which is presumably why it's suggesting it is the same. Now, I don't know enough about species to know whether that is actually a completely separate species and it shouldn't be in that grouping. But what I'd point out to you is that the way the clustering works, or various techniques for the clustering works, it will group together things which you would never spot if you were just eyeballing them. So the one below, the first one, we spotted quite easily because it all lined up together in alphabetical listing. Whereas that E1 could have been 1,000 records down. You would never manually spot that kind of connection. So that's where these clustering things come into their own. Of course, like I say, you do have to know what you, I guess, your subject matter to know that, oh yes, that is probably a typo. Someone meant to put an A there, not an E. Okay. So again, I'm going to say merge them. And then at the bottom of this screen, I've got options for merge, selected and recluster. So I want you to merge them, put them all together in into the same name as the top one, and then effectively repeat the operation of clustering. Okay, and typically you're going to click that one, and then you might want to repeat the exercise until there's no more clusters. Okay, again, you can try the other option and say, oh, see, that's a bit weird, but there's 40 of them, which is a bit worrying. Again, hard to say what they would be. That looks like a good candidate for merging. I'll merge that one just for the fun of it. Merge and recluster. Well, again, obviously I didn't merge them, so they still exist. So this is a mixture of it being clever in that it can find things in disparate parts of the data set, but it also is very much reliant on you understanding the subject matter to know if these really go together or not. In my case, I'm absolutely ignorant of these scientific species, so it's a bit of guesswork in my case. And when you've finished doing all the clustering you want to do, you can just click close. And you'll notice that in my list now, I've only got 19 choices, and I've got 437 of them as opposed to 435 I had before. Okay, so that is how you can cluster things. Very good for typos. The other thing you can do is you can split things up. You would like to think this wouldn't really be necessary in most cases because of what we said this morning about having each item in its own column. But it is there as an option. And what we're going to do, if we look at that scientific name again, there's obviously two words, and we can split them out based on the two words. It says scientific. I suppose it's like when you get genres and things like that of things. So there's a legitimate reason for wanting to split them out, I suppose, or could be anyway. So what we're going to do is we are going to do it on scientific name. We're going to say edit column, split into several columns. Let's get back there. Scientific name, edit column, split into several columns. Okay, and this brings up a little dialog box. By separator, well, by default it's assuming a comma again, but we want to replace that by a space. You can say split into most columns, but it's probably not worthwhile doing that. Let it work it out by itself. By default, it will remove the column that you're splitting. In our case, we want to leave it in there for comparison. And then we can just say, OK, leaving everything else the same. And what we will see, I'll have to move this along a little bit, where before we just had scientific name, now I've got scientific name 1 and scientific name 2. And at this point, I will draw your attention to the most annoying thing about OpenRefine is that it decides how wide the columns are, and there's absolutely no way for you to adjust it. So if your names get too long, they just fall off the end. But you can hover over them and you get a little pop-up tip like that. But for long names, it can be very, very annoying. Okay, so what we've got, we've split it on the space, and we've got scientific name 1, scientific name 2. It's just picked the names based on scientific name. We do have options for renaming the columns. Where do you rename the column? Okay, I'm going to check the note on where you rename the column, but you can definitely rename the columns. Try to change as a second column to change the name. Okay, that is just splitting them up. I've taken these aren't strictly true because we've got 1 and 2. That's okay. So I'll click on down our edit column, rename this column. Is how we do this. So edit column, rename this column. And there you get an option of changing the name. if you think about it, it's pretty obvious how this is going to work. If you try to give it the name of something which already exists, it's going to get upset with you. If you give it something quite unique, it will happily accept it. So certainly the minimum I would do for that is replace the space it has put in for you down here and replace that with an underscore for the same reason we discussed this morning. And similarly for that one. The suggestion is we might want to try and change that to species. That won't work because I've got something called species. Okay, so yes, you can change the names to something more meaningful, but it's not going to let you repeat a name. So I'm just going to cancel that and leave them as they are. And that's pretty much what that little exercise will say. Okay, just in passing, the undo and redo we haven't looked at. If you on the left-hand side here, where we've been playing with this filter and facets all the time, but there's another little tab up here called undo redo. This is all actually the same item. There's only two little items. It would be far nicer if they give you nice clearer boxes on them. But what we've got is this little list of things which we have done. Okay, and it sort of makes sense. Create the project. Yes, we did that. We transformed the cells to numbers. Yes, I did that. We know that because it turned green. We did a mass edit on 739 cells. That was the clustering, or the two clusterings that we did. And then we split the cells based on the scientific name. So these are effectively the steps that we have done. And what we can do is we can undo them and we can redo them. So if I go back one step, i.e. this line 4 has not been done, you can see I'm back to just my scientific name. I've lost scientific name 1 and 2 because it hasn't been done yet. And equally, I could go further back. I could go right back to the beginning of the project if I wanted to. And things would be there. So if I go back, if I go back to the beginning of the project, and move back down to you can see is now text again, whereas I had it as I changed it before. And if I go and have it undo them, I can redo them, click down there, that becomes numeric, and oops, where am I? I've got my scientific name 1 and 2. Okay, so this approach, if you make a mistake, you can go back. Okay, you've got to sort of go back up the tree, then back down again to possibly to correct things. But it does show you that it is tracking everything that you're doing. And we're going to make further use of that later on when we want to save the things that we've been doing. The final thing in this section is trim leading and trailing white space. Something that we didn't talk about when we were doing Excel, but it's a very common problem, especially, I think, not so much when you're putting the data in yourself, but it can happen, but when you're importing data from somewhere else. You quite often, in any text, say I had a value of white space, a value of trailing, it could quite easily happen that someone accidentally adds a space onto the end of trailing. Now, trailing with a space at the end and trailing without a space at the end is going to look exactly the same to you and me. They are totally different to a computer trying to compare them. Okay, so getting rid, or universally getting rid of leading and trailing white space is a very common action that you're going to do. Okay, and it's so common we actually have a common transform for it. So again, scientific names, edit cells, common transform, trim leading and white spaces. Oops, scientific name, edit cells, common transform, trim leading and trailing white spaces. If I click on that, it will get rid of any leading or trailing white spaces. Now, looking at the text in here, it didn't find any. Okay, it's still worth doing even if there's none, because you don't know, because you will not be able to spot that there's none. Okay, so leave it for it to decide. And I think the narrative seems to suggest that there should have been some in there. So whether the file has been subtly changed since this was written, I'm not sure. Okay, but again, trimming leading and trailing white spaces, just do it as a matter of course. It's very hard for that to be a mistake, even if it doesn't find any. But if there is white space in there and you don't do it, it can be an absolute pain to pin down. Okay, so there's some like basic things that we can do with OpenRefine. So the next little section is filtering and sorting. Well, in a sense, the faceting and the clustering is sort of filtering, but we'll do it a slightly different way this time. What we're going to do is, again, sticking with our scientific name, what we're going to do, we're going to apply a text filter. Rather than a facet, we're going to say text filter. So if I go into here, just go back into Facets, I'm just going to delete the ones I've got just to clean up. So almost back to where we were. Again, I'm going to go to scientific name, text filter. Okay. And what that is going to bring up is a little box down here into which I can start typing. And I think I might have ruined this by doing that combination before. And let me just see if it suggests another one. BAI. Let's try that. So if I start typing into this cell, BAI, what you can see is, this is based on the scientific name. What you can see is, based on the 3 letters, it's looking at a scientific name starting at the beginning, and it's found 48 matching rows which start BAI. Okay, and as I've now set this to 50 rows, I should be able to see them all on the screen. And if I go down there, they're almost all the same, with the exception, I think, of those last 2. Okay, where it's in a slightly different, well, it actually finds it doesn't necessarily start, it's looking for BAI anywhere in the scientific name. Just that the majority of them actually start with it. In these last 2, it's a second word which starts with BAI rather. So the next question is, well, how do if I only wanted, say, these last 2, how would I do that? Well, all I'd have to do is make this something unique to them by putting an L in, and then I'm reduced down to the 2. Yeah. So I can use that to filter the rows as well. How much text I put in there depends on how we find I want the filter to be. So it seems likely you'd probably want one or the other. So if I type in an O there, I'm now going to get the 46, i.e. the other 46. So again, a simple way of filtering just based on the values that are in there. Okay, what names are selected by this procedure? Well, we've just seen them. How would you restrict this to one of the species? I've just told you the answer to that. You just added another letter for one or the other, depending on which one you wanted. The excluding entries we've already covered. The way of narrowing the filter is to include and or exclude. Well, I showed you showed that being done on the previous facets. So there's nothing new there. Facet and filtering look very similar. Yes, I've just said that. A good distinction is that faceting gives you an overview description of all of the data that's currently being selected. So if I go back and just run that here, if this is going to something which is going to be unique, i.e. I've only got 46, that's fine. But it doesn't tell me anything about the ones which haven't been selected. Whereas in my standard facet, text facet, I'm getting all of the different types and how many of them there are. So if I go down to the bottom somewhere, oops, no, it was B, wasn't it? Yeah. So you can see there the BI omnis, whatever it is, you can see there's 46 there. And again, I can choose, as I've already showed you, I can choose to include them or exclude them. Okay. So again, that only does it on the first word. Okay.
Maybe you applied it. Did you apply that to scientific name 1, maybe?
Oh, yes, I have. I've done it to scientific name 1. Thank you, Alex. Yes. So had I done that on scientific name 2, scientific name up here, Facet, Facet. Now we've got the full names, yes. So there you can see the 46 of those, and if I go down to the bottom, or wherever the one was, the 2 of them there, yeah. And I can decide to include or exclude each and any one of those, or collectively if I wanted to. Excluding entries of cupboard, sorting. Okay, again, if you've got lots of records, chances are you're going to want to sort them. We discussed this morning about sorting of date and how it makes a difference if it's a string date or it's actually a date, i.e. an integer date. When you're sorting in OpenRefine, it's kind of quite flexible in that it's probably going to be easier to show you this as the example. So in any of the cells, let's do by scientific name because that's our favorite. Down the bottom here, or towards the bottom, we've got sort and 3 little dots, which means it's going to bring up a dialog. And this allows me to do sort. I'm going to sort by scientific name. And what I can do within the sort, I can tell it, well, pretend that it's text, pretend it's numbers, pretend it's dates. Okay. In this case, it's not really much choice because it's obviously text. And I can sort by text. I can sort in ascending order, A to Z, or descending order, Z to A. What I can also do, which is actually quite useful, again, assuming this is data I don't know, it's new data, I think we already decided there's a load of blanks in there. Now, supposing a blank for a scientific name is something sort of we might have to sort out, it might be quite useful for them to all appear first, irrespective of what we've said about the sorting down here. And what I can do is drag blanks and I can move it to the top. And then the blanks will always come at the top, regardless of how I've sorted it. And equally errors, and I've never actually come across an error, you can have them coming next. And then the validate values come last. So scientific name, by that. If I sort that, you can see, oh no, panic, all of these missing scientific names. How many of them are there? Well, in fact, I actually already knew that because it told me down here, because blank counts as a name. Okay, but you can bring, if this was something where there's far fewer of them and you needed to bring them to the top, it'd be quite useful for doing that. So at the moment, I'm just going to do that sort again. Once you've used sort on a column, it will come up, instead of giving you the ellipsis saying open the dialog, it'll say, well, do you want to go back to where you were? Do you want to reverse the sort, i.e. opposite order, or do you want to remove the sort? Okay, so in this case, I think I'm just going to reverse the sort. Oh, no. Reversing the sort won't make any difference at all because that only reverses the alphabetical order part of it. So all my blanks are still going to come to the top. So what I really need to do is sort, go back into there and put the valid values back at the top. Okay. So now we can see in the scientific names in some kind of order. Okay. If we want to sort by perhaps numeric type values, I think we've got record ID and we've got year. Okay. Supposing we wanted to sort by record ID, and then within the record ID, we're going to sort by the year. Currently, we're sorting by scientific name. So if I go to record ID and go to my sort, now I haven't used sort on record ID, so I get the ellipsis here, and it comes up with a very similar dialog, except that, let me just set this up as I go. Record ID, I want you to treat that as numbers because it looks like numbers. I'm not going to bother with any of this now. But the one thing I do want to change is I want to sort by this column alone. I want to start my sorting process again. Don't take into account the fact it's already sorted by scientific name. Okay. So if I click on that, I'm going to sort by record ID. And you see the record ID seems to be numerical. And then if I want to do that within the year, and the sort, I haven't sorted year before, so I've got the option of doing this. And again, I can sort as numbers. And I can sort largest or small to largest first. And again, the option of sorting by this column alone. Okay, so in fact, I think I should have actually done it this way first. I should have started with the year, sorted by the year alone. And now you can see that the record ID is not actually in order. All the 1977s have different record IDs, but the chances are somewhere down in these 1977s, I'll have the first two records as well. That's the first year. So having sorted by year ID, then within the year, I now want to sort it by the record ID, again by numbers. Now I'm not going to click sort by this column alone because I want to sort record ID within each year. And just to make it obvious, I'm going to say largest first. Okay, so the highest record ID for 1977 was 503. And if I page down far enough, I'd find the next year and so on and so forth. And again, you can sort on as many things as you want. It doesn't matter where they appear in the data set. You can still it's the order in which you select them for sorting which counts. Okay, and at any point you can restart the sort. Okay, exercise for you. Sort. Can you okay, I've explained that. I've gone through all of that. So sort by month. How can you ensure that months are in order? Okay. If you resort a column, that's pretty much what I've been saying. You sort by year and then sort by months, what have you. If I just sorted by months alone, I'd get all of the month 1 coming to the top, followed by all the month 2s for all 22 years and so on and so forth. But really what you want to do when you're sorting by month, you want to month within the years. So you'd sort by the year first, and then you'd sort by the month. Okay. So here's a little test for you. Sort the data by plot. What years were observations recorded for plot 1 in this filtered data set? Now, by filtered data set, I think it means the data set which I've accidentally undone because it's the one which has the text filter on scientific name. Okay, so if you have undone that, redo that again, so you're down to 48 rows, and then do a sort on the plot and find out what years there were observations. Okay. Oops. Wrong one. So we have a couple of minutes for that. I think 3 minutes. Okay, off you go. if you've got time, feel free to try the next exercise as well, which is just sorting by multiple columns. Or perhaps the last one where you're sorting the dates by year, month and day. Okay, so the question or the task was sort the data by plot, and the question was what years were observation recorded for plot 1. Well, if I'm going to sort it by plot, I'm going to do it in ascending, so all the plot 1s come at the beginning. Yeah. So sort by plot, sort, these are numbers. Just again, well, I must have something in, otherwise this wouldn't appear, so I'm just going to sort by this column alone. Smallest first, and that will bring up all of the plots. There's 3 items for plot 1, and I'm asked for the years 1990 and 1995. Yeah, everyone okay with that? The next one, sorting by multiple columns. Again, I did show examples of this, so hopefully it should be okay. Sort by multiple columns, yes. Sort will depend on yes. To restart sorting, yes, done all that. Sort by this column alone. You might want to look at for trend in the monthly data, clicking across it. How do you sort the data by month? How do you do this differently if you instead try to see all of your entries in chronological order? That's pretty much what I was suggesting before. So if I just do it by month, sort, numbers, just sort by this, smallest first. What I'm getting is all of the months 1 for all of the different years involved, and then all of the months 2. But it's far more likely that to do it, if I want it in chronological order, it is far more likely I need to start by sorting by the years, again as numbers, sort by this column alone, smallest first. And then within the year, I want to sort by the month. So here on sort by month, it's pretty much the same, except that I'm not going to check that box because I want to sort by month within the year. Which Has it done that already? Yes, 1989, 11, 12, and then for 1990, we'll start again at 1, 2, 3, or 1, 2, 4, and so on. Okay, so you can sort multiple items at the same time. And the final one is really just an extension. Well, if we can do it by year and month, we can do it by day as well. Okay. You can also just remove the sort if you want to just remove any sorting that you've been doing. And that is it for sorting. So single items, multiple items, you always have the option of undoing any previous sorts that you've had. And the point about moving the blanks and the errors to the top can be very useful. And why isn't this working? Oops. Oh, numbers. Okay, just before coffee break, we're going to have a look at numbers. And this is really introducing some of the other facets that we had. I've already pointed out that by default, everything comes in as text. When you're doing sorting, it doesn't matter because the sort operation gives you the option of saying, oh, pretend it's a number or pretend it's a date and what have you. But there are things where we do have to move things into a more obvious format from what they are. So what we're going to do is we're going to transform a few columns into being numbers, and we can pretty well. It says record ID, use that, and we can pick a few other ones that we want. So in our file, I've still got year's number, but never mind. It doesn't matter. If I go to record ID, edit cells, common transforms to number. Okay, and again, I'll get the green coming up saying, oh, it's only done this on 48 cells because that filter was in place. So I'm going to click on the, oops, missed it from there. If I go back up here, I can undo it by going up one, back into my facet. I'm going to get rid of anything hanging around here just to make sure I've got all 35,549 rows. And now I'm going to do it. Edit cells, common transformations to number. Okay. And you'll see it's all become green. That's fine. I've already got year there. So what you want to do is pick some for yourselves. I'm going to go for plot, and I'm going to change that to a number. Obviously, pick things which look as if they should be numbers. That would be useful. Common transforms to number. And I'm going to go for stake. I have no idea what stake is. Numbers. Okay, so you want to just play it up, follow on with what I'm doing. Just pick your own numeric values to change the numeric values. So you've got 3 or 4 which look green, as I've got here.
Sorry, Peter, can I just interrupt? There's a Miriam Jam on the chat has said that she doesn't have the option to sort plots, only within the column.
She doesn't have the option to
sort.
Sorry, I think I did something wrong at some point because the years are green, and when I filter the plots, I just get one entry like at 1985, and I don't know why.
Okay, well, under the facet filter, have you got anything here? You see how mine is all blank? Have you got anything in there?
Nope.
And how many rows does it say at the top?
Just one. Well, when I filter it in plot, then there's just one row.
Well, what is the filter that you've got applied?
So the year is green and says 1985, and the plot is, yeah, when I filter to plot 1, it just, or sorted, then it's...
You're saying you've only got 1 year, 1985, is that right?
Yeah.
Okay, well, I'll tell you what, go over to the left-hand side and click on the undo redo.
Yes.
Yes. And just systematically work your way back up the list until you get all your records back. Or in fact, if you wanted to, you can just go all the way back to the create project and start with a clean file. Yeah, because what we're doing now isn't dependent on what we've done before. Yeah.
Okay.
If you go back and just click on the create project 0, hopefully you should have all your rows back. Yeah.
But the years are still green for some reason.
Even
Oh
when
no, not if I go back to, okay. Right.
Okay, create project. Oh, I'll tell you what, I'll do this as well. Just create project. I'm going right back to the beginning. So I've got 35,549 and everything is non-green. Yes? Is that what you've got?
No, my file starts at 1982. Why does yours start at 1977?
I don't know, but does it say?
Can you just scroll? If you scroll up to the top of the document, maybe that's.
Has she sorted it?
What is
Well,
it?
if she's gone back to create project,
Yeah.
it should be the full file. Is it saying you got 35,549 rows at the top?
35,000, yeah, 49 rows.
Okay, but you're saying that the first entry
Is 1982.
is 1982. We haven't. Well, we can't do anything if we've gone back to. So. Okay. Well,
How about the sort? Is sort applied somewhere? Can you clean the sort? So there is the sort button at the top.
So Daisy is saying that she's 1982 as well.
Okay, so if we go up to sort, try saying remove sort.
Where? At the record ID or?
Well, it's only going to show if there was.
Now yours says 1982.
Yes.
There was sort applied to yours as well,
Yes.
Peter.
Yes, so obvious sort applied. Okay, so we've now got the same thing, yes?
Yes.
1982. Yes. Okay.
Yes.
Well, you can just start again from there if you like, and we're just going to set some of these numeric fields to being numbers. Okay. It doesn't matter what's gone before because we don't really need it. Yes.
Okay.
So for the record ID is the one it tells you to do. So we'll better do that one. Edit cells, common transformation. Oops. Edit to number, and then just pick a few other ones. Edit cells, comma, to number. So I've gone for plot. I'm going to go for period. Oops. Edit cells. To number, and perhaps one more, stake. Edit cells, common transform to number. Okay, so we end up with 3 or 4 columns which are numeric. Everyone got that? Now we can start applying numeric filters to them. So I'm going to pick period. And I'm going to say facet, numeric facet. Feel free to pick different ones if you like. It's not going to make that much odds. And what you can see here is, because these are being treated as numbers, it's actually giving me this bar charty type thing, and I can drag and drop and use the bars here, the handles, to filter the data. So initially, I've got all 35,000 rows in there. If I come down to say there, I'm now down to 14,848. I don't know what this period is meant to represent, but I think I am probably surprised that it has some negative values in it. 88 minus 62. That seemed a bit odd to me. Again, without knowing exactly what period it is, I can't really say, but I'd suggest that might be something that you want to investigate. Okay, so we can apply these numeric filters to whatever numeric fields we've got. So I can do it to the record ID, facet, numeric facet. Now that's probably a bit boring because there's undoubtedly one record ID for all of the numbers up to whatever the maximum number is, 36,000. Might be a few missing if it's going up to 36,000. I don't know. Okay, not a very interesting one to do. Let's try the plot. Now, I think we said this morning that the plots only have 24 values. All right. Oh, 1 to 25, I suppose, yes. And then you can filter on if you're only interested in what was happening in plot, whatever this is. I'm selecting accidentally plot 17. Or plot, yes, plot 17. I can filter down to get the 2039 records. Yeah. The other type of facet we haven't looked at is, again, it's reliant on numeric values, and that is the scatter plot facet. If I go down to facet, scatter plot facet, and click, what this shows me is for all of my numeric fields, columns, it's going to effectively give me a plot of one against the other. So for record ID, I've got the plot of record ID versus period, record ID versus plot, record ID versus stake, and so on. Okay, so I've got a complete set of all the combinations here. And what I can do from here is I can pick the one I want to look at in more detail. And the one that looks most interesting to me is this one here, record ID versus period. If you haven't made period numeric, you'll have it, or if you hadn't chosen the same set as I've chosen, this will look different with different column names down here. But based on the ones I've chosen, I'm going to look at record ID versus period. And then that will appear in the left-hand side as a little graph. You export it if you want to. But this also works in a similar way to the little, on the numerical where we had the little grab handles, you could drag things in. Here we can draw things, right? So if I draw something like that, where I don't think there's any little dots in there, I filtered out everything. Just kill that. I make the dot a bit bigger, but it doesn't really help if you're looking at my screen. If you're looking at yours and you've got a similar thing, it looks to me as if down here, I've definitely got at least one dot in there. I've actually got a handful of dots in there. And you see these are all negative values coming down here, which seems a bit odd to me because it almost looks to me that record ID versus period, you'd think it should all be positive. So again, I'm very suspicious of anything below the line here, and I might want to go and investigate that further. What this is particularly good at, it's not so much on this diagram because of that line going all the way to the bottom, but it's very good if you have outliers. You can potentially spot outliers. So they actually had quite a few. So all the ones there. Imagine this was a graph, perhaps a linear graph like this, and somewhere up here you seem to see a dot. That would be indicating an outlier. So by drawing the little box around it, you'd be able to filter on that and find out what that record was. So it's a very good way of finding outliers. Okay, it's almost tea time, so I just want to check if I've covered everything in the notes. Numbers, we've looked at the text filter, we started with that. We've done the numeric facet with the little drag handles, the scatter plot facet I've just shown you. Examine the pair of columns in detail. Well, I've just done that one to death, really. Scatter plot, the numeric one is useful if you want to try and get a range, a numeric range or a date range. It would work the same way. That's useful for that. The scatter plot, to be quite honest, because those graphs are so little small and grainy, I think the only real purpose for them is to try and detect outliers in the data. But it is very good in that because you just draw a little box around the dot and it'll show you what the record is. Yeah. Okay, if you feel free to try some of the exercises over coffee in your own time. And when we come back, we'll go on to the next chapter. Okay. Any questions? Now's the time to ask, please. No, you can ask questions anytime, of course, but before I go off for my coffee, that would be good.
Once you have like a list of refinements and you wanted to repeat it, say, on a file that updates every day, is there a way to call it?
That's after coffee time, Matt. Yes, okay. Yes, don't worry. Not forgotten, it's going to happen. Yeah.
That's a very useful question.
Yes.
What do
yes.
you do when you have loads of data files in a similar structure?
In your little session. There's one little thing I perhaps should have shown you before we leave this section. On the numeric facet, go back and have a look at it. What I've done on the period column, I could have picked any one, it doesn't really matter. I've selected a record and I've edited it. Like the facets, you can edit individual cells. So what I've done here, it had a number in there, I've edited it, and I've changed it to AAA, and I've changed the type to text. And when I've applied that, it has changed the value in that cell. Then when you apply a text filter, I beg pardon, just go through this. If I now apply a facet, a numeric facet, in addition to the little graph at the top, at the bottom, it will tell you that there is one numeric value in your column. The majority of them are okay. I've only changed that one, so it was okay before I changed it. If I uncheck the numeric, it will actually filter on that one non-numeric, and it's effectively highlighting potentially the column or the row which contains the error in that column. So again, a very useful way of finding non-compliant data types within a column. Yeah. Remember, when you're importing the data, it's going to treat everything as text, so it can't easily identify that kind of issue when it's imported. But by using changing things to numeric and then doing the filter, it will tell you if there's anything apparently wrong with the data. Yeah. So that's again a useful way of filtering down to any potentially erroneous data. So that's about all I wanted to say on the end of that. So the next sections we want to look at is how do we save and reproduce the work that we've been doing. And what OpenRefine does, we've seen it happening as we've gone along, and we've actually used it in anger. This notion of the redo, the undo redo section. Previously, I went back and created, you can go right way back to the created project. You can selectively reapply all of these steps. And these steps are obviously being recorded somewhere, because otherwise you wouldn't have this option of being able to go back to them. So the question is, how do we get hold of these steps if we want to save them for future use against a new file in a new situation? Before we do that, just to point out that this is only really applicable if you're going to apply them against a similarly formatted file, i.e., I think I said a monthly file which occurs every month, and you want the next apply the same set of changes to the next month's file. So how do you do it? Well, we're just going to click on this little extract button here, and this brings up this little display here. And what this display is showing us is on the left-hand side, it's showing me all of the things that it can export. Some things it can't export, like the editing I did on that cell a minute ago to change the value of that cell. But all of the major things which have been applied to the file, all the major transformations, just changing to from strings to numeric and what have you, they all have their separate little item, and they're all listed down here. And on this side of the screen, what I get is a file of, it's called JSON, and this JSON effectively is the internal way of OpenRefine keeping track of what it's been doing. Okay, and effectively, if I want to use the undo redo on this, it would actually consult this bit of JSON and decide what needs to be undone and what needs to be redone. So this is actually the instructions for OpenRefine to apply the steps that we've carried out. So we don't really have to understand this. We just need to look after it and be able to reapply it. So all we need to do is copy it, select it all and copy it. And then typically you might want to save that into a file, a notepad file. Paste, it's just text format, text, it's just a normal text file, so you can use Notepad or whatever you've got to fit saved in. Give it a nice meaningful name, save as, I don't know, okay, or transforms for whatever file, whatever is memorable to you, and you save it somewhere safe, okay? And then the idea is that next month or whatever, you start OpenRefine up again with your new data file in it. You can create a new project, and then you're going to apply all of these changes in exactly the same way. Now, to simulate that, what I'm going to do is, I'm just going to copy this, make sure I'm going to copy this to see, and I'm going to actually swap to another machine. This is a Linux machine, which is running OpenRefine. You see at the top here, probably can't read that, but it says Ubuntu, so Linux. OpenRefine works in the browser, so the interface to you is identical to what you might have seen before in your Mac or your Windows machine. I've just opened it up, so I haven't got a project on the go. So I'm going to start off by saying browse. I'm actually going to use the same file as we've got, because I know that's the right format. Open, click next. Yes, that's all right, create the project. So this is now a new project on another machine, somewhere else, someone else, some other time, but we're going to apply the same changes. And how do we do that? This is my starting position on the file. I'm going to click on the, you can see the undo redo is nothing in there. So I click on it, there's nothing no steps which we've carried out. I've just opened this project. So then I'm going to say apply. Rather than extract, nothing to extract. So I'm going to say apply, and I'm just left with an open canvas. And on there, you copy the file across. In my case, all I've done is I've just copied it to the clipboard. So hopefully, oops, oh no, I was hoping I can just paste that in. And that's what I've just copied from the other machine. Yes, the JSON. And then all I have to do is say click perform operations. It says working, it whizzes around, and you can see they're the things it said it was going to do. And you can see here that these have now all been changed to numeric values. Yeah. Had I applied some of the clustering, which I did before I wiped it out last time, then that also would get applied. Yeah. So this is the idea of all your steps are being recorded. Absolutely essential these days for scientific research. You can store it in a file. You don't actually have to understand what the JSON is saying. You just have to keep it safe. And then you can take that file into another OpenRefine environment on a different machine, different operating system, different time, and apply it to either the same file or a file of the same format. Okay. Don't need that anymore. Don't need that anymore. So, important things. There's not much in this little chapter. I've just given you the example. But the undo, redo, and the extract, I've mentioned on several occasions how undo, redo works. It tracks everything that you're doing. You can extract all of those sets of instructions, and then you just copy it somewhere as a plain text file. You don't have to understand the JSON. Then you go somewhere else, and then you do the same thing in reverse. You go to the undo, redo, and you apply it. You paste in the text file, and you say perform operations. It's that simple. Okay, yes, I did use a data set, same data set, admittedly, but at least I did it on across a different machine. So it makes it a little bit more realistic, I think. The next thing we want to do, how we're going to put this to use, well, what we've just done is really more useful for reapplying steps, but at the same time, it is documentation of what those steps were. Lots of information down the bottom here about reproducible sites and what have you, but essentially what we've just done covers the main part of what you're likely to want to do. It says here all changes are being tracked in OpenRefine. Well, in fact, they're not all changes, because individual cell changes aren't tracked. And as we found out just before coffee, the sorting isn't tracked either, because when we went back to the beginning of the project, the sort was in fact still in place. But the sorted order of the data set isn't in effect you applying any of the other transformations. So the next thing we want to look at is the exporting and saving data from OpenRefine. I said right at the beginning, and I've probably emphasized it several times in the meantime, that once you've started the project, you're only ever working on a copy of your data. Now, at the end of your working session, there's two things you might want to do. One is you might want to extract what you see on the screen, i.e. the data after all of those transformations. What we've just done a minute ago was extracting the steps that created those transformations, but now we want to extract the results of those transformations and save that potentially to a file, a CSV file typically. So that's one of the things you might want to do. The other thing you might want to do is take the whole project as a whole, as a single entity, and export that so that you can then take that to another version of OpenRefine and use it. So the subtle difference is that if I'm exporting the result of my transformations and my cleaning, the chances are I'm going to move it on to some other processing. So typically I'm going to want that in a CSV file. If I want to export it as a project, I'm just going to, it's only good for importing into another OpenRefine environment. Again, it won't matter what kind of machine it's on or where it is or when. It will just import it as a project. And then perhaps someone else can continue the work or whatever. So what we're going to do is saving. By default, it's saving the project as you go. Each step is kept, as we've just seen. If you close OpenRefine and open it up again, you'll see a list of your projects. You can click on the one, any one of them, to open it again at the point that you left off. Okay. If I go back into OpenRefine, I'm just going to, well, actually, if I do it on my other OpenRefine up here, I'm going to close this one. Oops, shouldn't have done that.
I think you just close the browser window, isn't it? I think that's how you exit. You just close.
Yeah, I had trouble opening it before, so I didn't really want to do that. There you are, open. I can go back to the beginning here. So here, if I've got multiple projects in, I can open them up, or I can import a project. Okay. And this is typically what we're going to want to do. So back to my other browser. This is all we've been working on. These are the ones that got the changes in. If I come up to the top right, I've got my export button up here, and it's a down arrow. So if I click on that, go on view, and there's various options I've got. OpenRefine project, archive the file. I can copy it out as this talking about the actual transformation I've made, actually the data you're looking at on the screen. I can copy it out into comma separated values in various other little formats. Okay, so we'll do that bit first. If I just take my file as it stands, and I can copy it out into comma separated values. Okay, and all it's going to ask me is, well, what do you want to call the file? I want to save the file. It's going to give me the name of the file name and put .csv onto it, so I can't actually name it myself. And then I can click OK. I'm not entirely sure what folder I was going to put it in. Text document. I'm hoping it's going to go into downloads. Downloads. Here we go. CSV.csv. It's just been created at 1546. There's only one file in. Because there's only one. I've only got one record in there because if I go back to it, I've got a filter on only one record. So let me just go back and undo my filtering. So I've got all of the records now, but I have made some changes. So record 3 should have AAA in it. Try that again. Separated values. Again. Have a little look. I'll just close that old one. Okay, so I've got a new version of it now. Just check out, here's a new version. Yes, new version here. And you can see now it's a far larger file. So if I open that file, for some of the changes you won't be able to tell because of the way Excel works. So I can't tell that these have been changed to numerics because they're just all dragged in as numeric anyway. But on this row here, you can see that that has been changed to AAA as opposed to the original, which didn't have that in. Okay, so what we're exporting here is what you are currently seeing on in the screen on OpenRefine. So if you do have filters applied, then only what is the result of the filters is going to be exported, which is kind of what you'd expect. Okay, so that's exporting the actual resultant transformations that you may have had. Okay, export. Oh, this one does it around first. Clean data. This is what we've just done. Export, tab separated or CSV, downloads it to a directory, and then you can just access that in a normal CSV fashion. If we want to export the project as a whole, we can do that by click the export button and then say export project. What this produces is a tar.gz file, which is typically used in Linux, not so much in Windows these days. And that again goes down to the download directory. And again, you move that across and then you import it. So we'll have a quick little go at that. Let's see if I can break it. So now under export, let's just make it a little more interesting. Let's put some kind of filter on scientific name. So I haven't got the full set of rows. And I'll say I want that one and that one. Oops, include that one and that one. So I've got 733 records I'm going to export. Again, this isn't going to export the data. This is going to export the whole project. So when I open this project, it should come up saying 733 matching records. So OpenRefine project archive to file. And you can see here, it's going to call it file name .tar.gz. I'm going to save the file. And again, that should appear in my downloads. Which I've got to have open somewhere. Downloads. So I can refresh that. Okay, and there's the file downloaded. I'm now going to have to try and get that moved across into my Linux machine. which I'm hopefully I can do by a drag and drop operation into there. And that's in my downloads folder. So that's the tar.gz file. So back to the Linux machine. I've opened it up. I'm going to import a project. I need to browse to where the file is. And the file is in downloads, tar.gz. That one there. I'm going to say open. Okay, it works exactly the same there. I can rename the project, which I think I might do because that's a bit of a long name. Moved roads. And then I'm going to click on import project. And there you can see the complete new project imported. If you look at the undo redo, all of the steps are in there. I'm not quite sure why that is saying, I don't know why it doesn't actually apply them, I don't think. Go back there, go back to there. Oh, it didn't seem to have a copy of my last transformation for some reason. But you can see here that the plots are all there, and my AA is in there as well. And all of the steps are there that I performed. For some reason, that last one isn't there. I'm not sure why that has occurred, but never mind. But you get the idea that you can take the entire project, wrap it up. It comes out as a tar.gz file, which again, you don't have to understand the format of, because all you're going to do is pass it to another copy of OpenRefine, which is going to open it up, and then you carry on from where you left off, or someone else carries on from where you left off. Okay, and any of the changes that you've made, so these are all numeric at the moment. So it's how to apply them. I'm not sure why I've lost that last step, but there you go. I go back to my other one, just check it was still applied. Oh, that's still saying 6 of 6. So yes, it did actually copy everything it said it was going to copy. So the filters, yes, they're applicable if you're exporting the resulting file, but if you're just exporting the steps, the filters aren't exported. But all the other steps are. So things which actually transform the cells are. Okay, so you can take, you can preserve that. I'm not sure if that would be acceptable as a data store for reproducible science, because it does rely on OpenRefine being available. But certainly, if you're collaborating with other people, it's certainly a useful way of moving the entire project around. Okay, exporting the clean data. Yes, we've just done that. Clean data or entire project can be exported with OpenRefine. I've demonstrated both of those. Projects can be shared with collaborators, and they'll be able to reproduce and check the results, I suppose. Okay, and that is it for that. I think we are nearly finished. Other resources with OpenRefine. I showed you right at the beginning about the OpenRefine official website, so I'm just going to open up again. I think I'm going to open up again. Yep, and in here there are the resources which are sort of available, but they're not necessarily that numerous. What we do have in here is the documentation, which I pointed out last time, online courses, a bit of support. There's a wiki for developers, because remember, this is open source. You can get the official documentation, because as you can imagine, there's an awful lot more in OpenRefine than we actually cover in this course. Even just importing and manipulating the different data formats which are available. You can also, in the later, and the version I imagine we all have, you can also import data from databases and things like that. So there's lots of things to find out in the official documentation. I assume it's relatively up to date, up to 3.4, where we're running 3.4.1 here. This might be for a slightly later version. But again, there's plenty of places in here to get help on things that you don't know. Extensions, again, because it's open source, you tend to get this market of people adding extensions. Translate into your own language if you want to. Lots of stuff there. This is obviously all residing on GitHub. There's a community, a developer community, and there's user communities as well. So you can, I've never used Data Carpentry, I've got to admit. I've got Twitter with OpenRefine, I've never tried searching for it. But there's lots of places that you can go. That's about it for that. Okay, documentation. The Using OpenRefine book, as I've said, as far as I know, it's the only one anyone has ever written. And much about OpenRefine history, there's that as well. Other little places where you can get some information on resources. I don't think these are all exclusively OpenRefine, but they cover the sort of area of data cleaning that we've been talking about. Okay. And other than that, we'll leave it to you. And I finished early. So, any questions? Before I can think of something else worthwhile to say on any of this, is anything not clear on the bits that we have covered? I think there's a lot of stuff in terms of the different types of transformations that you can do, all of these different facets that we can have, the custom text facet, filtering, transposing cells across rows into columns. That's not quite as useful as it sounds because it tends to spread out your data quite badly. It's not as useful as it might appear. Far better doing that sort of thing in R. Sorting we covered quite a lot. View, well, that's just viewing things. What is missing from there is how do I make the columns bigger, unfortunately. On the facets, we didn't cover the custom facets or the custom editing the cells, transform cell. What you can do is you need a bit of programming skills to do this. But if you want to do custom transforms, you can use what's called GREL, General Refined Expression Language. And the idea behind this is when it opens up, you're shown for whatever column you picked, plot ID in my case, it's going to show you what it currently is, and it's going to, oh, sorry, this bigger again. Was probably a bad choice really, but never mind. It's showing me what it currently is, and it's going to show you what it will look like after the transformation that is going to be applied. What transformation? Well, whatever you put in this expression up here. Now, by default, it just has a value of value, which means the same as it was, i.e. But the thing is, you can then apply different functions to this value to change it. That's probably not a good example of pick this. I'm just going to cancel that one and pick one like scientific name because we love this one. Edit column. Some text. Okay, so there we have the names that we had before. And in here, if I knew what all the functions were called, I could see as soon as I put a dot there, the value disappears because that doesn't make sense, and it tells me here there's a parsing error. Now, really, you really need to know what all the functions that are available, and you'll get that from the documentation. But let's have, I'm pretty sure there's a replace. What do I want to replace? I want to replace capital A, comma, with capital Z. Okay, close brackets. And there you can see what that transformation is going to do. It's going to take those A's and make them all into Z's. Okay. If I want to, what I can also do is, I don't have to stop there. I could start again and do a further transformation, but I can actually continue this and say, well, I also want to replace all of the BIL with ZYX. Yeah. And again, once I make that into something valid, it will show you what it's going to do in that transformation. So you can see here, yes, you do have a little bit of quite a certain amount of knowledge about what functions are going to be available to you. There's a lot more than just replace, I assure you. But the idea is that you can use the custom facets and the custom virtually anything else to write these little expressions which will do the transformations that you want rather than the common ones. I mean, the common ones are obviously very useful. That's why they're called common ones. But anything, excuse me, particularly that you might want to do, you can use the custom facet or the custom filters. Okay, and if I was to apply that, again, has it applied them? Probably haven't applied them. So if I now, let me just get rid of these ones, so I'm getting confused by them. And if I go back and do just again a standard text facet on the scientific names. Oh, doesn't seem to have done it. Did I not apply that? Okay, we'll try that one more time. So it's okay, you can see change there. So if I say okay, so these have all been changed. I'm not quite sure why it's not changing up here. Certainly all my A's have been changed in that. And if I select that. Okay, it's just changing the names in here. It's not actually changing the data names. But there are other transformations that you can use. Perhaps if I change, ignore that. And I had done edit column. Let's rename. No. Edit cells, transform. Let's try it in here. Value dot replace a node. Okay. No change. Keep original. So again, you can keep the original, or you can have it actually replaced. So I'm going to say keep original so we can compare them. And now you can see these ones have changed. Yeah. So now, if I do the text facet on there, it will again have all the Z's at the bottom. Yeah. So you can do lots of manipulations of the actual transformations of the data. And you see now, undo, redo, text transform on all of the cells. This one down here, and what I do, I change A to Z. So if I was to look at the extract, I've now got an extra item down here saying exactly what I did. So again, that could be copied and saved and moved across and what have you. Okay, about the other exciting thing I think to tell you.